stimulus again and again, each time for, let's say, half a second. So each time the stimulus is the same, but every trial you will see a different perception. Sometimes you see face, sometimes you see house. So why is that happening? What's actually in the brain that's determining this? So that's the key question we're after. So to do that, the paradigm is very simple. We show the stimulus for 500 milliseconds, and then we use fMRI to check your brain activity right before the stimulus onset. So this is like 2 seconds even before the stimulus onset. Okay, and the idea is that we're looking for brain areas that contain neural activity that can predict whether you're going to see face or house in this situation. And if there's any part of the brain that are causally involved in resolving this visual conflict, then this region should be able to become predictive about your consciousness. So this is the logic. So the question here, once again, is does pre-stimulus activity in visual cortex predict the subsequent percept or not? And if yes, where it is. So this is so the subjects are in the scanner, fMRI scanner, wearing red green glasses, and they're looking at this stimuli. So it's presented every 2 seconds for 500 milliseconds, and we have, of course, this Riber's stimulus, which is is superimposed face and house, and we also have control stimulus like this yellow face and yellow house, which is non-reverse, so you always perceive as a face and house in that case. So we have 3 regions of interest because we want to minimize our search in the brain. So we look for only 3 regions. The first one is the fusiform face area called FFA. This is a region that preferentially responding to face. So whenever you see a face, it will respond more than when you compared to when you see a non-face. And there's another region called hippocampal place area. So this is a region that responds preferentially to places, scenes, and buildings. And we also identify this early part of the visual cortex, foveal confluence. And once again, the hypothesis is that, well, if any of these regions is causally involved in determining your conscious perception, then we should be able to find these regions to become predictive about your subsequent percept. Okay, so here's one example run in which you see 6 trials. So there are a few reverse stimulus and 2 non-reverse stimulus here. And the example percepts would be like this. So for example, in this trial, they see face, and they see house, face, house. And of course, this will be always face and always house. And let me just show you some of the positive control here. So these are the trials that we should see strong activation in FFA and PPA. And this is and the results are as expected. So you're seeing the FFA region, and this is the mean activation fMRI signal in this region. So you can see that when so the red is when subjects perceive a face, the response is stronger than when they perceive a house. Okay, and in PPA it's the opposite. So when you perceive a house, it responds more than when you perceive a face. And in early visual cortex, they respond a little bit higher to the houses, probably because they are more high spatial frequency in the house stimulus. Okay, so these results are just as expected. They replicate previous findings showing that FFA responds preferentially to faces and PPA responds preferentially to houses. And it also shows that we have enough statistical power to capture any differences in the in this paradigm. Okay, now this is the crucial part. So for these neutral or ambiguous or reverse stimulus, what happens in the brain when some of them are perceived as a face and when some of them are perceived as houses? So, and does pre-stimulus activity in the brain predict the subsequent percept or not? So to check that, we simply sort the data into those trials that are perceived as faces and those trials that are perceived as houses. Okay, and we simply ask, is there a difference in pre-stimulus activity between these 2 conditions? And this is what we found for post-trial activity. So 0 is at the time we present the stimulus, and you can see that for these neutral stimuli, or for these reverse stimuli, when they are perceived as a face, once again, FFA responds more strongly than when these are perceived as house. So this has been shown before. But the key thing is that we're going to ask, well, is there any difference in the pre-trial activity or not? And you can see that it appears that there's no difference But remember, this is using mean activation of PPA, but of FFA. But FFA actually contains many voxels. So maybe when we're doing the averaging, we're losing signals here. Because one possibility is that, well, maybe their patterns here is different, but we're taking the mean, so they have the same mean. So to avoid of losing these information, we use a pattern information. And the idea is very simple. We're trying to capture, we're trying to ask, are there any difference between the two patterns or not? And to simplify the idea, we can simply take the odd rounds of data and check the patterns, and we take the even rounds and we check the pattern again. So if the pattern is different and consistent across these two different parts of the trial, then the pattern should be there again. So we can simply quantify that by taking the within category correlation, which should be strong and big, and minus the between category correlation, which should be weak. So we can take the within minus between, and the greater this value, meaning that the pattern are more different. Okay, and you can imagine that if this region doesn't care at all, then when you take within minus between, you'll be 0. So when we do this, we found that 2 seconds before the stimulus onset, there's already a pattern difference in FFA. Meaning that 2 seconds before you see the stimulus, the pattern in there are already like 2 kinds of pattern in there. And one would lead you to more likely to see face, and the other pattern would make you more likely to see house. Okay, and this is only happening in FFA, but not in PPA and this earlier part of the cortex, and I can try to explain more why this is not happening in there. But anyway, so this finding shows that, and also this is not due to any contamination from the previous trials, because we control for, we post-hoc balance all the trial history, and I can tell you more detail later how we do this. And just to know that there's no mean mode difference, but only pattern difference, suggesting that there's endogenous variations in neuroactivity pattern in this part of the cortex, and which are involved in determining which category will be perceived. Okay, so to conclude, to answer the question, does neuroactivity predict or bias what you're going to perceive when the stimulus is bistable? And the answer is yes. So the conclusion, in the first part of the talk, I've shown you that there's a way to look for neural consequences of visual awareness, and the result shows that after recognition, or after the content of your consciousness change, the neural representation would also change. And conversely, when there's a change or when there's a difference in neural activity, we are able to use this activity to predict what you're going to perceive in this binocular paradigm, binocular rivalry paradigm. So, so to conclude, although consciousness is still a major unsolved problem in science, but I hope I have convinced you that there are at least some part of it or some sub-problem in there that are scientifically tractable. For example, we can now definitely study which brain region contains the contents of consciousness. And we now have the ability to look for not just neural correlates, but we're moving forward to look for and investigate the neural consequences and even neural causes of consciousness. Okay, thank you very much.
Thanks very much, Brown. Now, could I invite both speakers to come up on the stage and field some questions? And let me, Brown, ask you, if you're not too busy collecting your laptop. Seems like there are a couple of unanswered questions, and that would follow from, this really fascinating talk. I mean, terrific. Both talks, I think, are absolutely first rate. So one question would be, what's causing, do you think, the activity, the preceding activity that allows you to predict whether it's face or house when you present the stimulus? What's the reason for the varied pre-stimulus activity? And the other is, what's the interpretation of consciousness based on these studies? Is it just the case that it's a threshold phenomenon that if the activity is higher, either in V1 or higher visual areas, that a stimulus becomes conscious. So have at it.
Okay, so these are all great questions, and we probably don't have answers yet, but I can try to do some speculation. So for the noise that's predicting the conscious perceptions, we've tried a few ideas. For example, we're testing, well, is this just mental imagery? For example, before each trial, there might be doing mental imagery on faces or houses, or they're trying to, or maybe they're expecting faces or houses, and which would lead them to more likely to see face and house. And we've checked that, and it doesn't appear that they're doing this, because first, the trial is fast, and second, when we check the pattern, when we check the mean activation right before the stimulus, there's actually no mean activation. So it's like right at the baseline. And this contradicts to the literature on mental imagery, because according to the literature, if they're actually doing mental imagery on faces or houses, we should see mean activation to elevates in FFA and PPA, but we don't see that, so suggesting that they're not doing mental imagery. And another thing is that if we check the activation pattern in this pre-trial, this 2 seconds before the trial, and we check the pattern, and the shape doesn't like the pattern after they perceive a face. Okay, so it doesn't seem that well. It's because they're the area is pre-activated for some reason, and that pattern is just like a face pattern, and therefore that leads them to see face. That's not the case either. So we've checked a few possibilities, but we haven't figured out what's going on. And so one speculation we're guessing is that this could be just pure noise in the system, and it just happens that you have these different pure noise patterns, and one would lead you more likely to go to one route, and one would lead you to go to a different route.
The second question is whether consciousness is just a threshold phenomenon.
That I don't think we have any answers yet, because there are many different theories about consciousness. Like, is this a threshold theory, or it could be like global workspace theory, like when this area is connected to many other regions, and when information is shared, then it becomes consciousness. So I think this is a great question, but it's very theoretical, and I don't think we have a great tools to test these hypotheses yet. But I think they're starting to have evidence showing that, it's probably not just threshold, because in a lot of the cases when people are unconscious and their activation in certain area, they're still equally high as when they're conscious. So simply using the threshold as a thing to determine whether it's going to be conscious or not is probably not enough in that case. Yeah.
Questions? Yeah.
Hi. I'm just curious whether there's been any study about neural activity when someone is dreaming, because I was confused. When I see real objects, I feel that there's something in the real object itself that produces the perception in my mind. It's not only the workings of my brain, but in the case of dreaming, it seems that only my brain works, and somehow I see things which are not real. So I was wondering if we could study the neural activity when someone is dreaming. Maybe we could find why those neural activities actually happen even without seeing something real. Thank you.
Yeah, that's a great question. And I think there are only a few studies on this, and this is because of technical difficulty, because you have to verify that they're dreaming, and they can say that, right? And so you have to use EEG, and if you want to combine EEG with fMRI, that's a bit difficult. And especially, usually they won't enter this deep dream sleep. And so anyway, so there are technical difficulties in there. But recently there are some studies using lucid dream. So these are rare cases where people dream and they know that they're dreaming. Okay, so it happens. So some people, they're dreaming and they know they're dreaming, and they can even control the contents of their dreaming. And so there are a few scientists, they train these subjects to report, saying that, okay, if you notice that you're dreaming, just move your eyes toward one direction or so, and so that they can know that they're actually dreaming and they're controlling the dream. And